Okay, welcome back. We change gears now and take a look at storage I/O control, a feature that is available with traditional storage. What do we mean by that? Well, if you remember from what we've been covering in this module, that basically means setting up some type of storage prioritization for traditional storage, meaning VMFS and NFS. And that's exactly what storage I/O control does. It's setting up a storage prioritization with, by default, equalized access of your virtual machine's access to the same data store. So those are our objectives here. We'll have you be able to describe what storage I/O control and how it balances the I/O load onto a data store, and also show how to configure storage I/O control. So let's first take a look at what it is like for a collection of ESXi servers, even a cluster of ESXi servers, where they're all trying to access the same data store. That's our example on the left. When you have a collection of ESXi hosts all trying to access the same data store, there is no coordination across the ESX servers in trying to create some kind of balance. If you happen to have some virtual machines that are very disk intensive and you have other virtual machines that are not disk intensive, you have the issue of the noisy neighbor, meaning that if you have these very disk intensive virtual machines like we see here, the data mining server and the print servers, they're taking a lot of the storage I/O bandwidth and therefore starving the I/O opportunities for those critical servers like the online server and the mail server or any other virtual machine, right? And those are actually distributed across the different ESXi hosts. And again, there's no coordination across those hosts in creating some type of balance or equalization for that matter, right? There's nothing coordinating. There's no central authority, right? Each ESX server has its own queue, its own storage queue. The LUN has its queue, but that's really it. The different hosts are all going to be competing to access that data store. If, on the other hand, you take a data store and you enable storage I/O control, which is actually disabled by default. So you can enable this storage I/O control on any VMFS data store that's on Fibre Channel or iSCSI, and you can enable storage I/O control on an NFS data store. These will then, by enabling storage I/O control, will place a central authority over all of the I/O operations to that data store. It basically places vCenter in charge. It centrally manages your storage I/O across the ESXi hosts. So again, while you'll have all the different VMs competing to access that data store, vCenter is watching the I/O access across the hosts and will actually instruct each of the different VM kernels on each of the different ESXi hosts and have the VM kernels throttle back the VMs for those VMs that are taking more than their fair share of the storage I/O bandwidth, and adjusting for favoring the VMs who maybe have a higher priority on that environment. So we'll by default create a scenario where all VMs have equal access. So those heavy I/O intensive applications aren't going to have a negative impact on the less active machines, but those VMs who do need the bandwidth will get that. If you would like to set higher priority on a per VM basis, like for instance, here we're putting VIP status on the online store and the mail server, well, that's not an actual label you assign anything. This is just a description, but you can assign higher priority for certain virtual machines, and then they will be granted their higher share access to the storage bandwidth. So take a look at how this actually functions. Basically, with storage I/O control, we can ensure that those most important workloads are going to get the resources that they need during times of contention, right? So we're basically using the same basic resource allocation settings that you normally would see for things like CPU and memory. And as we saw earlier in class, the same can be applied to network shares and network allocation settings on a distributed switch. So with storage, you have a storage IOP reservation, you have storage IOPS limits, and you also have a default share value, right? So by default, that's actually what happens. No VM actually has an IOPS reservation by default. No VM has an IOPS limit by default, but every VM does get 1,000 disk shares by default. So right there, out of the box, you enable storage I/O control, and all the VMs are essentially equalized. And you basically can adjust the shares if you like. This is the old-fashioned way. You would basically adjust the shares on the VM's settings page for each of the different virtual machines. What we have now, starting in vSphere 6, with this introduction of storage policy-based management, being basically fully, placed all throughout the product, from the placement to the ability to add, I/O filters. You can then basically make use of storage I/O control as an I/O filter. So we'll show you how this is done. But let's just take a look at the defaults, right? Again, the defaults are that every VM gets 1,000 disk shares, and every VM has no IOPS reservations applied, and they have no IOPS limit. So our example on the left, if you have two VMs that are competing for disk IO, they will be effectively treated equally. So for instance, they might both have the same number of IOPS per second, 1,500 in this case, and they have both about the same level of latency. So that's the default on the left. On the right, if you were to just edit the settings of a VM and say grant VM2 2,000 shares, leave VM1 alone with their default 1,000 shares, well, when there's contention, because that's again when shares take place, right? When there's contention, the VM2 would then potentially have double the IOPS, as we see here in our example, and probably will have it able to complete in half the time with half the latency. But that's not really how we apply storage IO control today, right? With this policy-based mechanism where it's now part of the whole IO filtering mechanisms, it's actually a more complete solution, which we'll take a look at. One thing to note though, how does storage IO control determine when it's time to kick in the different storage access policies? Basically, it's a method that is going to be measuring some form of latency and in a certain amount of the actual throughput that a VM is able to achieve. This is actually where things have changed around a little bit. In the original implementation of storage IO control, what was done was simply looking at the storage latency from when the IO has left the host and has arrived the storage location. And it basically kicked in when there was 30 milliseconds of what we call device latency. That is a pretty good figure for a lot of storage solutions, that if something has, reached a 30 milliseconds of latency, that's a pretty sure indicator there's a problem. But it may actually be too high for some storage solutions and too low for other storage solutions. It's kind of a place to start, but it's too complicated to have to think about what is a good level of latency to engage these different storage prioritization settings. So this has been changed in vSphere 5.1. So it's been around for quite some time now. We've had this new method called the injector-based model, where this, instead of looking at actual fixed latency numbers, what it looks at instead is actually the entire picture from when the VM starts using the IO system, from the moment it leaves the VM, goes through the VM kernel, passes through the storage system. The VM kernel will determine what is a VM's peak throughput, right? Based on everything, right? With the host, the network, your storage adapter, the storage networking speed and all that, it will determine what its peak throughput is. And then if the VM hits 90% of their peak throughput, that's about the most you're going to get out of it. And that's basically when we decided that's a time to engage the storage IO control configuration settings. So instead of having some fixed time value using this number called 30 milliseconds of latency, which is good for some networks, like I said, for some storage speeds, it depends on what kind of disk you have, it depends what kind of network speed you have. 30 milliseconds is basically just too fixed. So this is where this injector model works really well. It really doesn't matter what the underlying characteristics are. It's just if you hit 90% of your peak throughput, this is a time to engage. So that's really what the system does now. It looks across all the virtual machines. If they've all achieved 90% of their peak throughput, or any one of them have achieved 90% of the peak throughput, then they're going to start being impacted in the whole configuration, specifying to the appropriate VM kernel which VM kernel on which ESX server should be throttling which of their different virtual machines queues. So this is adjustable. When you go ahead and turn on storage IO control, you can select which type of latency model do you want to use. The default is using the peak throughput model, where it defaults to 90%. You can adjust that percentage too, by the way. If you'd rather go back to the old latency model where you can just set it to kick in whenever there is a latency of 30 milliseconds, that is also available, but that's not really recommended. Leaving it with the default is actually the best practice. So 90% of peak throughput, and see how this works. Now, the idea here is when we were using a latency model, that seemed to be a pretty good way to indicate that there is, some kind of contention, with the assumption that there was a linear model for how we measured, the overall storage environment, right? As load increased, so would latency. But it seems to actually be more effective if we were to compare load with throughput, because then that's not really quite a linear model, it's more logarithmic, and so that as load increased, throughput should increase, but eventually it starts to plateau and actually will level off. And that's what we're watching out for, so that when you hit that 90% of peak throughput, that's when things are starting to drop off, and it's time to start prioritizing, ensuring the VMs who have the appropriate share are actually getting their share their fair share of that overall bandwidth. So let's go ahead and take a look at what it is that you use to set up storage out of control, but we'll do that after a quick break. So see you in a few minutes.